Yes, yes.
Okay.
Okay.
Can I share
Is it better
my
you, yeah, you present your presentation by yourself? Okay.
okay? Can can you see my slide? Can you see my
Yes.
slide clearly? Okay. Okay. Uh, thank you for introduce me for this plenary talk. And first of all, let me give this opportunity to thank you, Dr. Professor Dr. Avi, and also organization of ICAMT 2021, and then also uh, to our president of MRS Thailand, Professor Santi Mansali, to let me be the representative for Thai MRS Thailand in this prestigious conference here today. My talk today will be on graphene technology in energy storage application. I'm, I'm, uh, I'm working at the National Security and Dual Use Technology Center under the National Science and Technology Development Agency. And also you can visit our website if you want to find more. But anyway, I also serving as the General Secretary for MAS Thailand as well. And also I would like to use this chance to acknowledge the funding agency of our research has been funded by Ministry of Energy, Ministry of Science and Technology and Innovations, also Energy Storage System Program under the NASDA and Energy Generation Authority of Thailand, and also some of the conglomerate companies working on the oil and gas like PTTEP and also PMUC. And an award that has been awarded to me under the Thailand Outstanding Research Award under the National Research Council of Thailand, also TRF Senior Research Scholar, and also Thailand Tole Science Foundations. And on the right side, I show you some of the facility that we are located in Thailand Science Park. Thailand Science Park is close to Bangkok. I think if anyone has a chance, especially on the bank in Bangkok, so I welcome and warmly welcome everyone to visit our research institutes. We are about only 20 to 30 minutes from the Don Mueang Airport, so really close. And also under the National Science and Technology Development Agency, we have about 3,000 researchers working on various fields of technology, including National Electronics and Computer Technology Center, Energy Technology Center, Nano Technology Center, and Biotech Technology Center. Okay, let me go through our today's talk. I would like to introduce you a little bit about advanced carbon nanomaterials. Because in our laboratory, we mainly focus on these materials, because the carbon nanomaterial has well-known unique properties that can be in various forms, such as if we classify it in with dimension, so we can classify into like zero-dimensional carbon nanomaterial like fluorine, carbon dot, or graphene dot. in one-dimensional, we are quite familiar with single-wall carbon nanotubes and multi-wall carbon nanotubes, for example. And also with 2- and 3-dimensional, we quite familiar with graphene and graphite, including the graphene foam, for example. But today I would like to mainly focus on 2D material called graphene, because it has a unique properties that is suitable for many various applications. The graphene is, I just give you a short introduction. The graphene is the first ever 2-dimensional material has been discovered by these two guys, Professor Andrei Gram and Professor Konstantin Novoselov, and also is a building block for the many kind of carbon nanomaterial. For example, if we stack it, we can have a 3-dimensional, or we roll it, we can have a 1-dimensional, and also if we can make various form of the carbon from graphene. And also the graphene has a strength that is about 200 times stronger than structural steel. That is really interesting. Also, they have a large surface area. The surface area is about double of the single-wall carbon nanotubes, which is about 2,630 meters square per grams, or about 4 soccer fields. And also they have a really good conductivities. They can carry more than 1,000 times electrical density versus the copper, comparable to copper. And also they have many kind of unique 2-dimensional electrical properties related to quantum effects on the surface of the graphene. Also, because the graphene has very thin layer, it's only 1-dimensional, 2-dimensional layer of the carbon. So they have a flexibility up to 20%. And also the transparency about 97.3%. But the most important thing is graphene can be fabricated based on the graphite, which is very low cost. For example, the cost of the graphite material is only about $3 per kilogram. So that's why it's really interesting, because it's cheapest form of the carbon nanomaterial ever synthesis, comparable to cheaper than carbon nanotubes and also fluorine. And also graphene can be applied in many applications, including conductive ink, in the display technology, in the LED lighting technology, also in the chemical sensor technology, and also definitely in the solar cell battery and supercapacitor energy storage application as well, because the unique property that's suitable for energy storage, such as the large surface area, large to the electrical conductivity, have a high charge carrier mobilities, high thermal conductivity, also high mechanical strength, also environmentally friendliness, and also transparent and low cost. For example, Samsung has been announced that they use the graphene in their battery in Note 10 series and S series, for example, to make it 5 times faster in the charging. Also, they can charge only in fully charged in 12 minutes, and 45% increased capacity comparable to non-graphene batteries, and also prolong the lifetime of the batteries. Also, for the EV application, Tesla also looking for something that we can make it fast charged. We can have a higher capacity for longer range, and also the longer lifetime of the battery. That's why we focus mainly on putting the graphene in the energy storage application to enhance the performance of the battery and supercapacitor. And let me introduce you the importance of this energy storage a little bit, because we are now moving forward to the new era of the energy uses. We move forward from the fossil fuel era into the renewable energy era. You can see we can use less of the oil, and we can put new kind of greener energy storage, energy source, such as the wind, solar, and also other renewable. Also including the use less of the oil in the futures. And also, if you see the mixture of the energies into the power generations, the mixture can be used less of the coal, oil, and also nuclear in the future, but we will increasingly use of the renewable energies and also the gas source as energy source in the future. And also the most important thing of the renewable energy is the energy storage system, because the sun doesn't shine all day long or all night long, and also the wind doesn't blow 24 hours. That's why it's the intermittent source of the energies. So we need something that we can store the energy in the storage system. Then we can use it in the time that we want. That's why the battery is the most important thing, and it's the most bottlenecks of the uses of renewable energies in the future. And also in the electric vehicle or EV, battery is also the mainly cause of the EV. More than 50% of the EV is the batteries tax cost. But the good news is the cost of the lithium-ion battery has been dramatically decreased since 10 years ago until now, and also will be estimatedly reduced furthermore in the futures. Should be less than $100 per kilowatt hour. And also the yearly demand for EV battery power has been dramatically increased exponentially in the future. So that's why battery and energy storage, we have a really high pressure in the demand and also in the cost reduction. You can see but the growth of the energy storage deployment has been increased fast in the near futures. But many kind of the energy storage has been invented and also used in the nowadays. For example, battery is one of the most important and widely used energy storage, but also other energy storage like supercapacitor, fuel cell, and also like a capacitor is another source of the portable battery system. But this plot show the Lagrange plot show the specific energies and specific power. You can see various type of the battery has been used nowadays. The mostly used is the lead acid battery, and we also use the nickel metal hydride battery. And nowadays we moving forward into the lithium-ion battery. And you can see that with the lithium-ion battery has a high specific energies, also a moderate specific power. But in the future, we have another type of the energy storage, like a supercapacitor, which has a higher specific power, but also they have a lower specific energies. So that's why we're looking something that energy storage that can serve both specific energy high specific energy application and also high specific power application. That's why other type of battery has been invented lately, like zinc air or sodium sulfur battery. And we're looking for something that is in this area with the graphene battery technologies. And also, that's we focus mainly not only on the lithium ion battery, we also focus on the beyond lithium or alternative battery, such as sodium ion battery, potassium ion battery, and also zinc ion battery. Because this kind of material has been abundant comparable to lithium material in terms of the availability on the earth crust, and also with the capacity. Also, some has the higher volumetric capacity, but some has a lower gravimetric capacity comparable to the lithium ion battery. So that's why lithium ion battery may suitable for EV application and also for portable energy storage. But other kind of the application like energy storage system for solar farm and for the wind farm, we have no need to use the lithium ion battery. We can use other kind of the battery for stationary energy storage system. And you can see the performance of various kind of the beyond lithium battery has a comparable operating voltage comparable to the lithium ion battery. Depend on the type of the electrolyte, and also the specific capacity is about in the same range of some of the lithium ion batteries. For example, aluminum ion battery and also the zinc ion battery has a capacity about 250 to 300 milliamp hour per gram. And that's why we focus on how to use our advanced carbon nanomaterial in the battery and supercapacitor. And many researchers around the world has been putting carbon nanomaterial in various components in the battery and supercapacitor. For example, in the anode, carbon nanomaterial can be used to retain the dendritic structure on the anode surface, or even used for the enabling the uniform charge distribution and also inhibit insulating passivation film on the anode. And also on the cathode side, carbon nanomaterial can be used for strengthening the cathode structure to improve the electrical conductivities and also to increase the electrolyte wettability. Not only in the cathode and anode, advanced carbon nanomaterial can be also put into the electrolyte system, also including the solid state electrolyte, to increase the ionic conductivities, to have uniformities of ion deposition on the surface of the anode and cathode, and also to enhance the stability and mechanical properties. Not only the electrolyte can be used in the separator as well to facilitate the ion conductivity, to strengthening the structure of the separator, and also to anchor the shadow active ion for some of the battery system. And if we specialize into the graphene also can be used in many kind of the beyond lithium ion battery application, just showing in this nice diagram. You can see that this can be used in anode, cathode, electrolyte, and separator in many kinds of various battery and supercapacitor. Let me go back to a little bit about how we synthesize our graphene. The graphene can be synthesized with several methods, including the mechanical cleavage, like Scott tape method that Andrei Kamenov-Solov has been invented and awarded the Nobel Prize. But there's an advantage is they have a prestige part graphene, but also the disadvantage is they have a very low production. But many ways to synthesis graphene has been invented lately, like the electronication, chemical vapor deposition technique, chemical technique like Hammer method, and also electrolytic exfoliation technique. But some of these in each technique has an advantage and disadvantage depend on application. But anyway, if we also focus on how to make a graphene in the mass production, like this plot show the qualities and the plot between qualities and the price. We're looking for something that has a high quality but low price. So it should be about here, but it's still waiting for our researcher to do that. But compared to other technique like liquid phase exfoliation or electrolytic exfoliation, we can have a moderate price with the moderate quality. But with mechanical cleavage, we can have a high quality but really high price. So that is still a room for research for the high production of the mass production of the graphene for high quality graphene. And also graphene has a two-dimensional, but we can construct the three-dimensional structure of the graphene using various techniques. One of it we call the graphene foam. The graphene foam, we use the template, like a nickel template or copper template, and then we grow the graphene using CVD on the surface of the template, and then we etching. We can have a pure graphene in 3D structural form. Or other type like zeolite, we use the MOF, metal organic framework, to be the template. We can also use that. And another kind of the three-dimensional carbon structure we call nanoporous carbon. This is really important type of the carbon because many kind of battery and supercapacitor use the effect of the high surface area effects. That's why we need something that can have really high surface area. So nanoporous carbon is one of the carbon that's suitable for energy storage application. And we can synthesize three-dimensional structure of the carbon with various techniques, like we can self-assembly from the 2D building block into the 3D structural material, or we can use I just mentioned about using template, and then we use CVD growth, or we can also use the spinning technique and then carbonization to make a 3D carbon nanofiber, or direct ink writing and then carbonization into some of the order or uniform of the pore size of material. So various kind of technique can be used. Okay, the rest of the talk, I would like to focus on our recent research work on how to use graphene in energy storage application. In our center, we focus on two type of the two technique of the graphene synthesis. One of is the chemical vapor deposition. We also have a research on how to make a graphene film or graphene foam, and also from the various sources of the carbon, like a CO2 flare gas, waste flare gas, also the other kind of the carbon source gases. And also another technique we call chemical root synthesis. We focus mainly on electrochemical exfoliation because we have been filing the patents on the how to make graphene from the graphite using electrolytic exfoliation technique. And this both graphene production at our center, we can apply into many applications, including the battery. Okay. For example, in our research work, we use the nickel foam as a template, and then we CVD graphene on top of the nickel, and then we etch away the graphene and then composite with the conductive polymer to make a nano composite. And also another research work that we first invented is how to use the zinc oxide nano tetrapod as a template for making graphene aerogel. We can use the zinc oxide nano tetrapod like this, and then we CVD growth the graphene on the top of the surface of the zinc oxide tetrapod. Then we can etch away the zinc oxide and leave only 3D hollow graphene nano tetrapod. And it's really, really fluffy and also really light material, and also has a really high surface area. And also another kind of the carbon nanomaterial that we recently focus is on how to use the bio waste from the various sources, such as the wasted coffee ground, also from the palm kernel shell, also from the bamboo waste. And then we pyrolysis and carbonization and make it a biochar, and also activate it into the activated carbon material. And we have a technique to control the pore size of the carbon and make a suitable nanoporous carbon material. And this nanoporous carbon can be used in many type of the battery, like zinc-ion battery and also sodium-ion battery. Let me give you example of how to use our graphene and carbon nanomaterial in zinc-ion battery. Let me introduce you a little bit about zinc-ion battery. Zinc-ion battery is the mainly focus in our center because we're looking for emerging beyond lithium-ion battery that has comprised of the abundance material such as zinc, that we have a spare resource in Thailand, and also with the non-toxic material, and with the highly safety and non-explosive battery is really important for some application. And the battery can be recycled up to 90%, and also high volume, and also high volume capacity, and also low cost. So we have a research on zinc-ion battery based on aqueous electrolyte, and also on the manganese dioxide structure. We put graphene into the our zinc-ion battery system on various components, such as coating graphene on the zinc cathode, and also putting some of the carbon nano tubes into the manganese dioxide, for example, to increase the capacity and to protect the dendrite problem. And you can see that we successfully make a pulse cell out of it, and our capacity is in the range of 180 to 200 milliamp hour per gram, which is comparable to some of the lithium and battery. And also energy density is in the range of 180 to 250 watt-hour per kilogram. And the power is in the range of 50 to 500 watt per kilogram. And the voltage is up to 1.8 volt per cell. And you can see that if we put in the Ragonate process that I previously showed you, our graphene zinc-ion battery is about here. So it's has the same performance as the lithium-ion battery in terms of the specific energies and in terms of the specific power. And also another kind of battery that we recently focus is on the graphene sodium-ion battery. As you know that sodium-ion battery has a sodium ion to replace the lithium ion. So the mechanical structure and also the principle is quite the same as the lithium-ion battery. And also we can use the same equipments and production line as the lithium-ion battery. That's why we have a pilot plant built for sodium-ion battery in Thailand. I will let you know later. And we focus on the using of the sodium because the sodium has an abundant material compared to the lithium. It's about 1,000 times more abundance. And also performance of the sodium-ion battery compared to the various type of lithium-ion battery is quite comparable. So in terms of the cost and energy density, that's why in Thailand we mainly focus on the sodium-ion battery. And also lately, like CATL is one of the biggest producer of the battery in EV, has been announced that sodium-ion battery will be the futures of some of their production in the near future. And also other startup and also other battery companies has been recently putting their products in the sodium-ion battery in the market, in the various market like e-bike, e-scooter, also using the stationary storage system, and also in the EV application. So in our center, we putting graphene into the sodium-ion battery in the various form, such as mix it into the anode system. Also, we also use our wasted wasted agricultural material to make a hard carbon, which is one of the important material for the sodium-ion battery, because in the anode we can have a hard carbon as an anode. And this shows the performance of our capacity is in the range of about up to 400 milliamp hour per gram, which is quite impressive. And also the number of cycle now has been proved at more than 500 cycle. And another type of the battery that we recently focus on is on the aluminum-ion battery. As you know that if we see the abundant rank of the aluminum is about is about the third of the most abundant material on Earth. Even has more than sodium, and the cost is quite low compared to other type of the source like sodium and lithium. And also capacity has been reported that has a high volumetric capacity and quite high gravimetric capacity, and also electrode potential is quite moderate. So it's suitable for portable energy storage application. But the main burdens of this aluminum-ion battery is electrolyte. That's why we try to solve that problem using graphene. And also, we firstly demonstrate how to use the graphene to increase the performance of the aluminum-ion battery by using graphene coated on the separator. And you can see that we can also use the graphene oxide to put into the alpha phase manganese dioxide in the aluminum-ion battery. And I can show you first of the charge discharge performance of our aluminum-ion battery is in the range of about 200 milliamp hour per gram, and also about with graphene can increase the specific capacity and increase the number of cycle, percent of retention of the cycle. And the last energy storage device that I would like to introduce you is the supercapacitor. Definitely, supercapacitor is one of the energy storage that is between the battery and capacitor in terms of the specific energies and specific power. And they have found in many applications, such as the high power density application, because they have a very fast charging and discharging. And also they have a long life cycle, more than 1,000 times compared to the batteries, and also high reliability and wide working temperatures. In our center, we use graphene in supercapacitor in many form and application, such as we put the graphene mixed into the nano composite and make a electrode out of it. For example, nowadays in our labs, we can reach about energy density about 300 to 350 watt-hour per kilogram, and capacity is about 300 to 500 farad per gram. And if we put into the lactonate pot compared to other type of the energy storage and also to the commercial supercapacitor, we are about here. We have a higher energy density with the same power density. This shows some of the we put into the form of the cylinder cell and also pouch cell. I show you some example of how to mix the graphene with the nano composite. For example, we put graphene composite with the polyaniline and using special surfactant stabilized, and we can use the graphene synthesis by electrolytic exfoliation, and we can reach about 690 farad per gram. It's quite impressive. So it's quite high because it's the combination of the EDLC and also the pseudo-capacitance effects. And another composite that we recently work is on the graphene and carbon nanotube wrap polyaniline nanofiber composite. We can show
2 more minutes, Mr. Adisorn, 2 more minutes.
Sure. We are about close to finish. We can reach about 600 farad per gram. And also with we play around with the organic electrolyte system using phenyldimine mediated organic electrolyte to increase the performance of the nitrogen drop reduced graphene oxide electrode in the supercapacitor, and we can reach about 530 farad per gram, and we can demonstrate it compared to the commercial lithium-ion battery and commercial supercapacitor. And also play around with the facial electrosynthesis of the hydrophilics polyaniline co-dope with the polyphenyldiamine nanostructure on the surface. So we can enhance the performance of the supercapacitor close to the batteries. Okay, and also the lead, not only the graphene, the waste carbon, the waste coffee ground has been used in the supercapacitor as well. So we use the wasted coffee ground and then we carbonize it and coat it on the surface and demonstrate up to about, let me see, more than 10,000 cycle. Okay, with energy density is with capacity is more than about 100 farad per gram, and also focus on the high energy density supercapacitor using ionic electrolyte system to increase the operating voltage of the supercapacitor up to 4.5 volts, which is one of the largest volt in the supercapacitor ever achieved. With 4.5 volt, we can achieve about energy density up to more than 100 watt-hour per kilogram. And specific capacitance more than 165 farad per gram. Okay, with the conclusion, in my talk, I emphasize on the importance of energy storage, which is the key of the renewable energies. And also I introduce you various forms of the advanced carbon nanomaterial, including 2D, 0 dimension, 1 dimension, 2 dimension, and 3 dimension, and focusing mainly on 2-dimensional graphene material. And also I give you some of the recent research on our use of the graphene in the beyond lithium-ion battery and also supercapacitor application, including zinc-ion battery, sodium-ion battery, and also the supercapacitor. And the last but not least, I would like to thank all the our team in our center, and also I would like to give you a little bit about introduction of the alternative battery pellet plant that we have funded from the government, and we on the process of building this battery pellet plant, and we will finish it about October next year, and is located in Eastern Economic Corridor in Rayong province, which is about 2.5 hours from Bangkok to the east part of the Thailand, and really close to Chonburi, Pattaya, and also to Rayong province. That's why we will use this pellet plant, which has the capacity about 1 megawatt-hour per year, to research on the various kind of beyond lithium-ion battery, including sodium-ion battery, zinc-ion battery, and magnesium and aluminum-ion battery. So if you have a chance to visit us after October next year, I will really welcome you to visit our alternative battery pellet plants in Rayong province as well. Thank you very much.